Hello, Legacy Sabers, Marsh here. So today we're going to add and subtract rational expressions. You want your notes and then a pen or a pencil today. You might need to do a little bit of math, but it's going to be very simple multiplication. So, general fractions. How do we add fractions? Well, we need to find a common denominator, right? And we found common denominators by multiplication. So I look here and I see, well, a 5 and a 10, well, common denominator for them would be 10, right? And then I say, well, 2 times 5 is 10, so I got to multiply the numerator by 2 as well, so that gives me a 2. Well, 10 is 10, right? So that can stay as a 7. And then once I got to a common denominator, I added my numerators over the denominators of 10. So I'd have 9 over 10 for my answer. Same thing we're going to do today, but with x's and some factoring and fun stuff like that. So, in order to add or subtract rational expressions with like denominators, you need to add or subtract their numerators. That's all you're going to do. Don't mess with their denominators. Then you're going to make sure your final answer is simplified if you can. So let's try a problem here. I have x squared over x squared minus 3x minus 28. Subtract 12 minus x over the same denominator. So notice these are the same. So first thing I'm going to do is deal with my numerators. I am subtracting. When you're subtracting, I like to make this a plus and then distribute that negative behind it. So that way I don't get confused on the signs and all that fun jazz. So I got x squared plus x minus 12 for that numerator right now. Once I add them together, over x squared minus 3x minus 28. Now notice, guys, this does simplify. So I'm going to factor the numerator. That is x plus 4, x minus 3. 28 is 7 and 4. I need a negative 7 to give me that negative 3. Notice the x plus 4's do cancel off, so I'm left with x minus 3 and x minus 7. Now, don't cancel those x's. That would be killing another kitten. You don't want to do that. Don't kill kittens. Now, you're probably saying, well, Mars, that's wonderful, but what if they're unlike denominators? Okay, what we're going to have to do is find our least common denominator. So that means the smallest, quote-unquote, number that can be in the denominator. We make common denominators by multiplying, not adding, so you cannot add stuff. You're definitely going to be needing some factoring. Let's try an example. So first thing I notice is I do not have common denominators. So here's how I find common denominators. Make note, LCD, that's my least common denominator. Everything that's in the denominator needs to be present in the least common denominator. So I have a 3 and I have an x, because that is 3 times x. So I'm going to make note of that. I need a 3 and I need an x. Well, this x squared, well, I can kind of break that down into an x times an x. Now, what I'm going to do is see, do I have an x, one x, in my LCD? I do, right? There's an x right here. So that means I do not need this x. I already have that present. But I do need this second x. So I'm going to multiply by x as well. So my LCD is 3x squared. Now I need to look. What do I need to multiply this denominator by to get the least common denominator? Well, it needs an x, right? So I'm going to multiply by an x on the top and the bottom. Same thing. What do I need to multiply this denominator by to get this least common denominator? Well, 3, right? So I'm going to multiply the bottom by 3 and the top by 3. So I'm going to rewrite. I got 2x over 3x squared plus 15 over 3x squared. Notice, guys, now I have a common denominator. I can now add my numerators. So 2x plus 15 over 3x squared. Nothing factors, so we are complete. We do not need to simplify any further. Let's try another example. So let's first factor my denominators. So x squared minus 4, that is x plus 2 and x minus 2. This denominator does not need to be simplified. So first I'm going to find my LCD. So I'm going to take both of the things in this denominator and put that in my LCD. So one's x plus 2, one's x minus 2. Now I need to look at the next fraction, an x minus 2. Do I have an x minus 2 present currently in my least common denominator? I do, right? It's right there. So actually I don't need this x minus 2. It's already been present in the common denominator. So it looks like that is my common denominator. So now I gotta multiply my denominators by what's missing. Nothing's missing in the first fraction. So I just get to rewrite that one. I'm missing an x plus 2 on this denominator, right? So I'm going to multiply the top and the bottom by x plus 2. So that's 3x plus 6 over x plus 2x minus 2. Now, since I have done that, I can add the top together over the bottom. I do notice I can take out a 7 out of this numerator, but that's not going to help at all. It's not going to simplify any further. So I'm going to call my answer done. Let's try the last example of the night. So this is factored. So let's factor x squared plus 10x plus 25. Be an x and another x. 5 and 5 makes 25. And I need a positive. So 5x plus 5x, that's 10x. So it looks like x plus 5 would be that. So first thing I'm going to take from my first denominator, I need an x plus 5. So I'm going to look in the second denominator. Well, I already have an x plus 5, so I don't need another one. But notice there's 2 x plus 5s present in this denominator. That tells me I need another x plus 5 in my LCD, because there is 2 present under one denominator. So that means I need to have 2 present in my least common denominator. Now, since I found that, I get to multiply the fractions by what they're missing. So I have an x plus 5 only down here. I need another x plus 5. So I'm going to multiply the top and the bottom by that. Nothing's needed for this denominator, right? So that can stay as is. There is a subtraction sign, so I am going to change my signs here, so I don't have to worry about that. 4x plus 20 over x plus 5, and then plus a negative 6x plus 1 over x plus 5. So I'll get a negative 2x plus 21, it looks like, over x plus 5, and I'm going to be lazy and put a square there. Now this does not factor anymore, if you notice, so I can stop there with my answer. And that's the end of the video. I know finding least common denominators is kind of confusing because you're dealing with x's. We'll look at a couple of them in class, so in case you have questions or whatever, we can talk through them. But until then, see you later, Sabers.